Nice. So our integration checklist. The first one is you know f prime, right? And so what I'm saying is the integral of f prime dx is f plus c, right? So you recognize that you took a derivative of a function and you recognize the derivative. That means you know the function as well, right? For example, the integral of 1 over 2 square root of x dx, right? So we recognize that derivative, right? I hope so. We've been doing it so many times. So, so the solution is
square root of x.
Good, plus c, plus that constant of integration, right? We don't need the constant of integration when we're finding areas. We do need it when we're finding antiderivatives, okay? So remember, fundamental theorem of calculus says, okay, derivatives and antiderivatives are inverse functions, and the antiderivative can give me the area under the derivative curve. So two pieces of that fundamental theorem of calculus. One of them is an indefinite integral, like this one. One is a definite integral, where I hit the bounds, right? So our second thing on the list is the power rule. So, for example, if I see the integral of x to the n dx, I know I'm going to undo that power rule of the derivative. So instead of the last thing I'm doing is subtract 1 from the exponent, the first thing I'm going to do is add 1 to the exponent. And the first thing I'm doing is multiplying by the exponent. So to cancel that, I have to divide by the exponent, the new exponent. Right? So power rule. So example, we did all these already, right? Just going through them quickly.
Yeah.
To have one nice list. So example, 3x squared plus x dx, right, would be 3x squared, and I'm going to add 1 and divide by the new, plus x, add 1, divide by the new, plus c. So x cubed plus x squared over 2 plus c. For the most part, when we're doing integrals and into Calc 2, when we do more derivatives, we don't care about making things into a single fraction unless I ask you to do that. So in this one I could get a single fraction out of this. No big deal most of the time. If I want it, I will ask you to do it. Otherwise, you can just leave your integral as it comes out, naturally. Okay, and then we never include the plus c into that cleanup of the antiderivative. We just let the c hang out by itself, do nothing with it. Step 3, we're looking for tricks, right? So, and just so you know, often what happens is we're doing these integration methods. I might be up to integration method 8, and then I have to go back to integration method 3. And then I'll do some more, and it goes to integration method number 1, right? So, and I don't care about the numbers. I'm just putting them in a list because it's the list I think makes most sense to think about as you're doing integral problems, okay? So tricks, coefficients, move in or out, multiply by 1, add 0, divide and conquer, long divide. So these will happen as I'm doing pieces. As I'm doing things, you'll see these happen, right? So I'll give a couple of quick examples here. How are we doing here? I feel like I had a really strong cup of coffee and I might be going too fast, but you're going to let me know.
This one feels okay.
And again, everybody should notice that I sent out an announcement of all the stuff I want you to do to prep for the Chapter 5 test and, of course, for the final. So a couple of these tricks, okay? Not all of them. You'll see the add zero and the divide and conquer. Friday probably, if not definitely Monday, and of course Wednesday. So I'm not going to do all of them now, but just know it's an option. These are some common options. So for example, a real simple one, 1 over square root of x dx looks an awful lot like method 1, right? Looks an awful lot like method 1, but what am I missing?
The 2?
Yeah, the two downstairs, right? So I know I can multiply by 1, so I'm going to multiply by 2 over 2. Because I need a 2 downstairs, right? So now I have 2 times the integral of 1 over 2 square roots of x dx. And now I know this part in blue, right, is square root of x. So I get 2 square roots of x plus c. So if I see I'm just missing a coefficient, I can bring it in by multiplying, right? I can bring it in by multiplying. Log divide is a good one to do, but I want to do. I have to do another method first. Go ahead.
You have done a problem with
I did
it before.
one with long divide, but let me save that for the good ones, right?
Got it.
So, but you'll see me do all of these tricks. And number 3, these methods don't have to be in order. Okay, these little processes don't have to be in order, but again, it's just what makes sense to me. So, fourth one, we're starting to talk about U subs now. So, U subs, I think I have 4 U subs. So 4, 5, 6, 7, yes, 4 U subs. And then, and I think I only got to 2 U subs, but here we go. You're going to let U equal f of x and du equal to f of x dx. So what I'm saying here is you should see a function and its derivative in the same integral. And nothing else. That's really the key. You should see the function and its derivative in the same integral, and there should be nothing else. A coefficient is fine, of course, right? A coefficient is not a problem. So, example. I have the integral of e to the 2x dx. And I got this. I don't know if it's really a divide and conquer, but if I say to you, use a U sub here, you've got 2 choices. You've got the inside or the whole function. But I'm pretending I haven't taught you how to use the inside U sub yet, which is next. But this is e to the x times e to the x dx. Do you agree?
Yeah.
Yeah. So e to the x is my function. The derivative is also e to the x. But I want to make sure I follow my little rule here. I'm going to let u be e to the x. Take the derivative of that. I get du equals e to the x dx. Now, normally, what would I do with my derivative? I do d dx of e to the x, right? Which is just e to the x, right? Remember, my e to the x is u, so now I have du dx equals e to the x. And then let's pretend I'm cross multiplying. You can see my du equals e to the x dx. We're doing something from Calc 2 here called solving a separable differential equation. Chapter 7 in Calc 2. So I'm kind of cheating it a little bit, right? Saying I'm cross multiplying here. But now I make my sub. What do I have? I have the integral of u du, right? Do you see that? The green is e to the x, and the blue is du. Oh, sorry, the green is u, the blue is du. And now I'm back to step 2, level 2, power rule. This is u to the first power, right? So it's u to the 1 plus 1 all over 2 plus c. So that's u squared over 2 plus c, but u was e to the x. And you see I get e to the 2x over 2 plus c. How is this?
So it's a little bit fast on the last bit.
Okay, so once I get to this purple piece, right? You're okay with that, right?
No.
Okay, well, remember I said, do I see a function and its derivative? Do I see a function and its derivative? Yes. So let u be the function, right?
That's for our original, yeah.
Yeah, that's the whole process.
It'd be like a function taking form u.
Yeah, exactly. I'm changing the variable only.
Yeah.
Okay.
Okay.
So I get now when I get this purple box, I know how this is a power rule. All I have to do is add 1 to the power and divide by the new power. So that's what's going to happen. Is you're going to do one of these methods. It's going to turn into another method, right? If you look at my test, I have planned for Friday, next Friday, right? I had approximate an integral with 4 rectangles. I had solve this integral with an infinite number of rectangles. That's 3 problems already. And then I have 4 more problems that are going to be integration methods. Well, how do I do 12 methods in 4 problems? Because they turn into each other. I'll start with something at the most difficult level. It'll turn into a divide and conquer. It'll turn into I recognize what it is. Right? So I'll be able to ask 4 questions and get every one of these methods in. Off soon.
So I remember using like u subs to find the derivatives in like high school.
Yes.
I'll have to review, but like when you picked u and you picked du, which one did you pick? Du as e to the x dx because it was closest to dx. I remember.
Yeah. So these things are all kind of products, so they can be separated from each other. Like 2 times 3 and 3 times 2 are both 6. So they don't have to be right next to each other. But clearly I am multiplying e to the x times e to the x. Right?
Mm-hmm.
Yep. So it's a good thought, and it's simpler than that. And you'll see I'll have one in a little bit that seems like it's not exactly as it should be, but it's still there as a product, and then I can rename it as a du. So you'll see that happen pretty soon. Yeah.
Okay.
Okay, good.
Can you note down really quick what would be u du for something like the derivative of a radical x?
Derivative? No. Like, that's not a u sub. That's not a u sub.
Oh.
So that's why that's level 1. I know that derivative. I don't have to do any work at all. And by the way, on Symbolab, right, as I'm practicing, I can use Symbolab. So if I'm a little bit too lazy to take my antiderivative, if I get a little too lazy to take my antiderivative to see if I'm right, I can always go to Symbolab. There's other ones that do this, by the way. This is just the one I like. I used to use Wolfram Alpha.
Yeah.
Grad school. Through grad school, I used Wolfram Alpha. That's what saved me.
I knew about that one since high school.
So you can see I have an integral here. I don't want to do a definite integral. I want to, so let me just see. I probably should have searched for Symbolab integration. Oh, here it is. Oh, here's my integral, right? So, so if I do e to the x times e to the x dx, enter, it's going to tell me the u sub to use. Where's my u sub piece? It didn't tell me. All right, but I'll do one later. It will tell me. It doesn't like this particular function I typed. It would rather do this one. But because I'm forcing it, I'm making it up, right? It would rather do this one, and it should give me the u sub now. It'll say u is 2x. There it is. You see e to the u? So apply a u substitution. So u is 2x. So we're going to do that one next, okay? So just hang on for me. But Symbolab's a nice way to check it. There's lots of others, okay?
So what's the difference between having the u be represented by e to the x and having
good
the u
question.
be...
Just because you say it's this method doesn't mean it's also not another method. So, but the idea is to look for these methods in the order I'm giving you. It will simplify your life a little bit. And you'll see my very next u sub is going to be obvious when you use it. Okay? So let me do one more like this, okay? So an example where I see a function, right? I see a function and its derivative. So do you see a function and its derivative? Say yes.
Yes.
Very good, Jesse. Now I'll ask someone else to tell me what the function is. Let him off the hook. What function do you see?
Got it.
ln x?
Yep, ln of x. What's the derivative of ln of x?
1 over x.
Good, 1 over x dx. Do you see a 1 over x dx? Do you see a 1 over x dx?
Yes.
Yeah,
Oh, that's my
already better.
du. That's du. Right? So now I have the integral of 1 over u du. Back to level 1. I recognize the derivative. Everybody with me here?
Yes, okay.
Good. What's the derivative of, what did I take the derivative of to get 1 over x, or 1 over u?
ln of x.
ln of x.
ln of u, right? But I need the absolute value. The Shams is leaving the absolute value on. I want you to put it in, plus c, right? And what is my value of u?
ln of x.
Nice. So I have ln of the absolute value of ln of x plus c. And my question is, do I need the absolute value? Does ln of x ever have negative outputs?
No.
Really?
Not unless you raise
Really?
it to a higher power now.
Really? Look at the graph.
Well,
Look at the graph. Is ln of x ever underneath the x-axis?
Oh, well, okay, yeah.
Yes, so it means I need the absolute value, right? Because it could be taking on.
So it's going to bounce.
Yes. Yeah, the graph of y equals absolute value of ln of x, I'll put in purple, is this guy. Right, it takes all those negative numbers and puts them up as positives. Yes, Subsoon?
Okay, so I remember there being a rule that we can't like put a negative inside the ln function.
Correct.
But since this is the absolute parentheses is around the whole function, we do need it.
Exactly. So these outputs could be positive or negative. So if I wrap them in absolute values, I kill the negatives. The negatives become positives. So then it's allowed. And notice our issue with this is not a calculus issue. It's a pre-cal issue. You got to look at the function, look at the domain, look at the range, right? Figure out if you need the absolute value or not. So I've assumed this one kind of took on your question. Notice the 1 over x is not, I'll do it in quotes, closer to the dx, right? But it's still there as a product. Right, okay, good.
So if this problem was something dealing with e to the x squared, is something like that, and you try to do
wait
this...
Wait for me. E to the x squared can't be done. It's a Calc 2 problem that we do. It's probably at the very end of the course where we finally learn how to integrate e to the x squared. All right, here we go. Next level. This is u sub part 2.
But that function doesn't go under it. It doesn't have any f of x's that are negative.
Don't just stay with me right now. Stay with me right now. We don't have to create anything. We just have to be where we're at right now. And the creative part is going to be you doing integration methods and figuring out what process you're using, what process you move to, what's the final answer, double checking by taking a derivative. That's where I want you to get creative, okay?
Yep.
Okay, level 5, u sub part 2, let u be the inside. So this is officially us undoing the chain rule, right? Remember when we said we have a complicated interior function? We need to use the chain rule. So when we recognize we're doing a derivative with a complicated inside, we are going to be undoing the chain rule, and we're going to let u be the inside. So this one is pretty obvious, and you'll see when we start just doing examples, if there's a clear inside, try it, right? If there's a clear complicated inside, try it. Our next level is downstairs u sub. So if there's a clear downstairs, our next level is some kind of u sub, but then leftover x's, right? So 4 levels of u subs: a whole function, an inside, a downstairs, or one of those and there's leftover pieces, okay? So for example, the integral of sine 2x dx, is there an obvious inside? Yes, right?
2x?
Yeah, exactly. So there's an obvious inside, so I let u be 2x. And then du is what?
Sine?
Nope. Only look at u. 2 dx, right? Du is 2 dx. Do I have a 2 dx? Do I have 2 times dx?
Yes.
No.
Not necessarily.
No. So I have to multiply by 2, which means divide by 2 to cancel it. And now I have sine 2x dx. And notice now in green is du, and in blue is u. So I have 1/2 of the integral of sine of u du. You will get used to it, okay? You just have to practice. And if you look at the Chom's problems I gave you, they all have the solutions written out. So you could cheat a little bit and say, well, can't figure out the U sub. And then eventually you're going to, eventually you'll start to trust yourself and try something. And it's okay. Once again, it's okay to try something and it not work, and then try something else. But this is now level 1, right? I know the antiderivative of sine, right? Antiderivative of sine is what?
Cosine.
Good.
Sine.
So c minus 1/2 of the cos of u, right? So that's minus for the, right? Because I go past the negative for antiderivatives. So I get 1/2 times the negative cos of u plus c. I just reordered them. And I know u is 2x. So c minus 1/2 cos of 2x. And is it wrong to write minus 1/2 cos of 2x plus c? No. You could do either one. So obvious inside is what we're looking for, right? So let me show a problem from our textbook here. With an obvious inside. So again, in the textbook, and I put this in the announcement today, numbers 1 through 57? Yeah, 1 through 57 odds, right? Because you have those answers. What do you think? Anything obvious inside here?
There's an e to the x cos e to the x.
Nice. There's definitely an obvious inside there. Perfect. Let's do that one. Number 12. E to the x cos of e to the x dx, the integral of. So this is 5.5, number 12. And of course you could do all the evens as well, right? Because you can just, if you're right or not, either by Symbolab or like on your test, when I tell you, show me you're right by taking the derivative, right? So on your test, I will ask you at times to show me that you got the answer correct by taking the derivative of your answer. And it should get back to the original problem. So there's definitely an obvious inside here. I don't know if it's going to work yet, but I try it. So I say u is e to the x. And that's this one, right? This is my inside piece, right? And what's du? E to the x dx. Do I have it?
Yeah.
So I've got cos of u du now, right? This is now the integral of cos of u du. Oh, but I know the antiderivative of cosine. It's sine, right? So sine of u plus c, and of course u is e to the x. Easy. These are easy. How are we feeling? It's about practice. You know that, right? It's about practice. And your friends, your true friends, will forgive you. Okay? If you say, listen, I've got 100 integrals to do this weekend. I can't go out. Right? And now it's also a good thing to do is to do 20 of them, go out, come back and do 20 of them, help with dinner, do another 20 of them. It's good to break it up too. But you want to be practicing right away. You don't want to wait, right? So start doing the integrals. Your true friends will forgive you. The people that aren't real friends with you will forget about you. But so what? A little less sleep, maybe. A little less socializing. Less gaming, whatever you're doing. Okay, next level. Unless you want to do another one.
We could do another one really quick.
Sure.
Please.
Let me show the Sean's outline. So this is the PDF I posted today to y'all. And on this one, you'll see there are formulas for all the integration methods, right? So notice this is an F prime. Do you see that? And that gives me the F. So that's our level 1 problem, right? It's saying you can split up the integrals. I think that's obvious. It's saying you can move the constant out of the integral. Here's my power rule. There's my level 2, right? So et cetera, et cetera. So it gives all of these formulas. It just takes time to unblur. It gives all of these formulas, and then it gets to solve problems. So in the solve problems, that's 1 to 71 I want you to do. And you can do all of them, of course, right? Because the answers are there, and you know how to check the answers by taking the derivative, right? The only thing they don't do is the absolute value when you do that ln one. So I'm looking for an obvious inside here. Any of these, and 9 is fine, or 10. Which one do you want to do? 9a, b, c, d, 10, 11.
11 goes with dx.
Yep. So we'll do 11. On this one, there's 2 insides, right? There's 2 insides, so the choice would be to take the more complicated inside. So I've got the integral of x plus 3 dx. I've got, so this is Sean's number 11. The integral of x plus 3 over, don't tell me, I forgot already, x squared plus 6x to the 1/3. Yeah, x squared plus 6x to the 1/3 dx. I like the dx as a like bookends to the derivative, right? So my integral and my dx are like bookends, right? They're holding up the piece that I'm integrating.
Yeah, I feel like that makes a little bit more sense. I was kind of confused.
Yeah, so clear. So here I can think of the numerator as an inside. I can think of the whole denominator as an inside. But in my denominator, there's an inside of that inside. And that's what's giving me the hint to try u is x squared plus 6x, right? And so what is du?
Two x plus 6.
Nice, 2x plus 6 dx, right? 2x plus 6 dx. So you can see that I'm going to be able to get the 2x plus 6 easily by doing what?
Combining u.
Multiplying by 2. I multiply by 2. I have to undo that. I multiply by 1/2. Now, upstairs, I have 2x plus 6, and I have my dx, so that part is du. Yes, Afsun?
Since it's like 1/2 and 2, is it the same as multiplying by 2 over 2, or is it different?
Yeah, 2 over 2. Yep, which is 1.
Okay.
Yep. So I like to multiply by what I need and then cancel it.
Yeah.
Yep. So it looks like I'm back to level 2, power rule, right? Right? Do we agree that what's in blue on my first step, on my first line here is du? And then I still have the 1/2, I still have the integral, I still have that 1 over x squared plus 6x all to the 1/3 power, but that stuff inside is u. So I have 1/2 times the integral of u to the minus 1/3 du. Everybody with me?
No, not really.
Where are you not with me? Are you okay with the choice of u?
Yeah.
Okay. Are you okay with du?
Yes.
Good. Are you okay with me multiplying by 2 and then dividing by 2?
Multiplied by 2 then divided by.
I multiply by
Where?
2 to get what I want, and then I divide by 2 to cancel it, because I don't want to change the problem, right? I want the problem to be the same problem. So since I'm multiplying by 2 and dividing by 2, I still have the original problem. But by multiplying by 2, I get the du I need, right? Do you see it? I get the du I need. 2x plus
We're
6.
decomposing the outside to fit what's gonna be on the inside
I'm
of-
multiplying by 1.
of our u.
I'm multiplying by
Well,
1.
yeah,
That's it.
yeah, it's decomposing by multiplying by 1, but it's like taking it apart to try and make it become 2x plus 6.
Yeah, multiplying by 2.
Oh,
Cancel
I guess
that, divide by 2.
they kind of gave us an easy one because it evenly distributes to.
Yes, but
2x
you're going to
plus
see
6.
one that doesn't work out so nicely pretty soon.
Yeah.
When I get to method 11, okay?
Okay.
So let them give us slow pitches for now. It's fine. We'll hit them out of the park.
I think it's another one of those instances of like it's where your brain is like thinking that there is something there
Yes.
when really it's more
Don't
simple than.
overthink it. Let things happen. Let things happen. Improvise. Try something, right? You'll see you can be pretty good at this if you can just be a robot. Just have your list and then try one of those things. Of course, don't try the first time on the test. Practice, right? Practice. You have to practice. So, I'm ready for my power rule. I'm going to add 1 to my power and divide by the new power and add my constant of integration. So I get u to the what? 2/3 over 2 times 2/3 plus c. So I get 3/4 of u to the 2/3 plus c. And u was x squared plus 6x. So 3/4 of x squared plus 6x to the 2/3 power plus c. Done. Easy. Easy. Once we figure out the right u sub, it's easy. Because it turns into something else. It turns into an earlier method, right? So how are you going to know if you have the wrong u sub? It won't work. It won't work out. You'll make your u sub and it will get ugly. It'll get messier. It'll get more complicated. It won't work out, right? So don't force things. Don't fake it. Let things fall apart if they fall apart, right?
Yeah, I guess if you can't see something you can do quickly to make
Then it's the wrong
that
choice.
other part
Exactly. Then it's the wrong
function.
choice. That's right.
But whatever, if you can see it, then do whatever you can to multiply by 1 and just
Or one of the other processes. Yeah.
modify the inside.
Yep.
And,
Mm-hmm. Nice. Let's go. Go ahead, Marcus.
Yes.
Sorry. Yep. Scroll.
Yeah. No, not too much. Yeah,
That's
you
the
can
whole
do it.
problem right there. That's the whole problem.
Thank you.
Yep. Marcus, give me a heads up when we're ready.
Oh, yeah. I'm done.
Nice. All right, next method. So that was method level 5 of my integration methods. That one, if you see a complicated inside, you probably will jump to quickly. You'll just go right to that method. This is another level of u subs level 3. I'm going to be taking the downstairs as u. So 6th method, u sub 3, let u be the downstairs. the entire denominator, right? So let u be the entire denominator. So it'll be obvious, right? Well, now look at this last problem we just did. Is there an entire denominator?
Yep.
Yeah. But when you do the derivative of that, it's a mess, right?
It's harder than doing the top.
Yeah. But again, if I see a denominator and the denominator itself has an inside, I'm going with the inside one, right? And that's why I put that one first in my list, because I'm thinking if I don't have a clear inside and I do have a fraction, it's probably, right, the downstairs is what I have to pick. I'm just having a little bit of a brain issue right now. Let me just look at our textbook for a clear downstairs. So I like number 33. Sine 2x over 1 plus cos squared dx. So the example is sine 2x over 1 plus cos squared x dx. So do you see an inside here? Does anyone see an inside beside me?
There's a 2x.
2x is inside. What else is inside? Somebody else, not Jesse. Anyone else see another inside?
The 1?
Not the 1.
Square?
The square is the outside downstairs. Cos is inside the square. So there's an inside of 2x. There's an inside of cos. Okay, and you'll see that happen. You'll see that one need to be used. So for example, right here, if I realized that my downstairs was not correct, then I would try cosine as my u, because that's inside of the square downstairs, right? And if you remember, 1 over 1 plus u squared du is arctan of u, right? So that's where I would need that inside. U is the inside there. Okay, anyway, so this has clearly got a downstairs, right? And maybe I don't see the insides quickly. Okay, but let's pretend I did see the insides. Well, if u is 2x, du is 2 dx. Well, I can get the 2, but what the hell do I do with the 1 plus cos squared? Right? I don't know what to do with the 1 plus cos squared. So, not obvious. I can't just multiply by a coefficient to get what I need, right? If I let the cos be u, so this one failed, then du is negative sine x dx. But I need sine 2x. I can't get a 2 inside the function, right? I don't even know what the inside of the function looks like, right? I've got a soda machine. I can't see the inside, right? So I can't manipulate the inside, right? You can also remember when we were doing those squeeze limits, you can't move the 2 out of the trig, right? You can't move that 2 outside of the trig, right? So that doesn't work. And making the mistakes is good for you. Trying things and not working is good for you. The thing you got to be careful about is don't panic, right? Don't panic if things don't work out. Try something else, right? So u is the whole downstairs, 1 plus cos squared x. Du, well, the 1 goes to 0, and the cos squared goes to what? 2 times the cos of x times the negative sine of x. Well, we agreed there. Missing one student today. Abraham. Abraham's missing. Do we agree with that u and the du?
Yeah, I've done cos squared and sine squared enough times to...
Good. Good. So
Recognize.
I can recognize my identity here. This is negative sine 2x dx. And I almost have it, don't I? I almost have negative sine 2x dx. I just need a negative, and of course I have to cancel it with a negative. So I'm multiplying by 1. How are we doing? So now I have the opposite of the integral of 1 over u du. So I get the opposite of the ln of u plus c. Everybody with me? U is 1 plus cos squared, so I get the opposite of the ln of 1 plus cos squared x. Oh, absolute value. Sorry, forgot my absolute value, plus c. But of course, in this case, I don't need the absolute value, right? Because 1 plus cos squared is, cos squared is always positive, right?
It'll always be above.
Always be positive. So I get negative ln of 1 plus cos squared x dx. Oh, sorry, plus c. And you can put the c out front. I always would ask my professor, why are you writing it again with the c out front? And he'd say, well, because it's a shorter answer. You save ink. I said, but you just wrote the whole problem over. You don't save ink. But if we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 6, 7, 8, 9, 10. One stroke, right? So one stroke better. One little less piece of code. So let u be the downstairs, right? Let u be downstairs. Should we do another, or can we go to the next method? These are, am I right? This is easy?
It's starting to make sense, but this one I definitely want to practice right away, after.
Can you put the where put the negative sign, please?
Yep, right here. This is the whole problem.
Okay.
And I know we tend to practice things we enjoy, so you're going to have to fake it till you make it. If you hate doing this stuff, why are you going to be an engineer? So fake it until you make it, and you'll realize it'll pay off in the future. Okay? You won't remember the pain, right? You don't remember the pain of birth because life is so good. Even when life sucks, you get a slice of pizza or something, right? It's great. So when you finally finish your degree, you'll realize it was all worth it. And it might just be the relief of being done, but then once you get a job and start working and making money, not saying you're going to love your first job, but it's going to literally pay off.
Why did you replace 1 over u?
So I remember I picked this method is let the downstairs be u, right?
Yes.
So and then I figured out how to get du, right? So I got u, I found du, and I manipulated it to get the du I wanted. And then all I had to do left is multiply by 1 in the form of -1 times -1.
The first one that was we used u subs was taking with ln and
Were you talking about our processes?
yeah.
The first one is a whole function. Second one is an inside Third one is the downstairs. Fourth one is a U sub, and we're about to do this one, but you'll have leftover x's.
Yep.
Okay, so I call this, they're all kind of change of variable. We're changing into the variable u. But as I'm trying to change into the variable u, I'll have some leftover pieces. And then what do? Right? So that's coming up next. Wait for me, please. Off soon?
Yeah, can we do number 7?
Oh, yeah. 7? Yes. Nice. So x sine x squared dx. Good. Oh, but that's an inside one, but that's okay. I don't mind. I don't mind. What's that?
No, I meant the next method. I thought you said.
Oh, next method. Next method. Let's do one more with the downstairs, okay? Let's do one more with the downstairs.
Maybe 13, or no, that's upstairs.
15 is a downstairs, right?
Yeah, it looks like.
15 is a downstairs.
Because it's just one. It's just one upstairs.
Yep. Yeah, let's do 15. So 1 over 5 minus 3x dx. 1 over 5 minus 3x dx. So clearly there's a downstairs, right? I don't really see an inside here. I can think of the numerator as an inside, the denominator as an inside, right? But no insides of the insides, right? We're looking for that super interior inside to be saying we're undoing the chain rule. So downstairs here, I get 5 minus 3x, that's my u. du is what? Negative 3 dx. So I want to multiply this thing by negative 1/3 and by negative 3. Right? So the double negatives cancel, the 3's cancel. So I have negative 1/3 times the integral of 1 over u du. Does everyone agree?
Yeah, I agree, but where did you get that negative 1 over 3?
Well, I multiplied by 3. Do you agree? I multiplied by negative 3, right? Yes?
Yeah.
Okay, but I can't. I can't just go to my bank and say, all right, 2 times my bank account. But if I went in and said, okay, I want you to double all my money and then divide it by 2, they would agree with that. They'd think I'm crazy, but I get a free lollipop, you know? So I can't just double something. I can't just triple something and keep equality, but I can triple it and then divide by 3. I can negate it and then divide and multiply by another negative. I'm trying to keep equality. And the only thing I'm allowed to do is multiply by 1 or add 0. So I get negative 1/3 times the ln of the absolute value of u, all plus c. And I notice that u can be negative, so I know I need my absolute value, so that's 5 minus 3x, all plus c. I probably could get rid of the cube if I wanted to. I probably could get rid of the negative if I wanted to. This is good enough for me, but I'm going to shock a couple of you with my pre-cal skills. The negative coefficient means reciprocal inside the ln. The 1/3 means cube root inside the ln. But this one's fine.
Is that because, like, if it was squared, it would be like 1 over 2?
Yep. Yeah, no, yeah, ln of m to the n is n times the ln of m, right?
Yeah.
Yeah, for pre-cal. So I'm just manipulating that to get... I don't know if I saved any strokes here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No. Either one's fine.
Yeah, can you zoom out, please?
Yep, there's the whole thing.
I like problems like these at the end, because when I go back to do more problems, I want one that's super simple, because then I just know the method. There's nothing extraneous going on where it's like a extra step. This is just denominator.
Yep.
U sub. It's only U sub. Everything else is like we beat it to death.
Upson, question?
If we didn't have negative 1/3 and it was just 1/3, we wouldn't really have anything to do because it would just be like the 1 cubed, right? Or would it be the 5 minus 3x cubed?
Yes, it would be a cube root, yes.
Of the top, okay.
Remember, if you're not taking the next math course in this summer, I want you reviewing your trig, reviewing your pre-cal, and then really get chapter 3 down for calculus and chapter 5, right? No chapter 3 and chapter 5. You can let the applications go. You obviously, if you can do derivatives, you know limits. So chapter 2 and 4 are not really stressed in Calc 2. We do some limits with L'Hopital's, but you know, I think you're all pretty good with that. So you're reviewing your trig, you're reviewing your pre-cal, you're reviewing chapter 3, you're reviewing chapter 5. If you're not doing calculus 2 in the summer. If you are doing calculus 2 in the summer, you have to do the same thing, but you only have a week or two to do it. Right? So,
I like deadlines.
yeah. And
If I have a whole summer to do it, I won't do it. If I have 2 weeks to do it, I'll do it.
don't do that. You got to learn how to be a better student, okay? Learn how to
I need to
chip
set
away
my
at
own
things.
deadlines.
Yes, learn to chip away at things. Learn to practice every day. That's why I'm really good at watching TV, because I watch every day.
Hey, I'm pretty good at watching YouTube too.
Yeah, I'm pretty good at that too.
You.
The thing, the news. Go ahead, Pedro.
I know, like I was just complimenting your joke like that. If watching TV is like a profession, it's my profession.
Nice, yeah. I can even skip the commercials and everything. The thing about the summer and fall vaccines, it's not going to be required for students. So still suggested, right? And we'll see, because things are getting worse again. But just so you know, go ahead, Alan.
Just went into
Okay.
Stained Glass Pub yesterday, and it was packed full to the brim. There was nobody wearing masks. I mean, I guess there's no point when it's a packed Stained Glass Pub.
Even the beers were filled to the brim, huh?
Yeah, it was crazy. I mean, honestly, I'd be getting off topic, but you know, it was great to see a place packed like that, I guess.
Yeah, the super spreader event. All right, let's next method. Here we go. Next method. Our next method is, I think I'm calling it 7. Doesn't matter, right? This list doesn't matter. The numbers don't matter. The names don't matter. But I'm trying to give you something as a starting point. What should I look for first, right? So number 7 is our final level of U subs. So level 4. But there's going to be, so it's going to be some function, some inside, some downstairs, but there's going to be leftover x's. You make a U sub. And there.
Can we zoom in a little bit, actually?
What do you mean zoom in?
Or like, just so it's a little bit bigger, that's all.
Oh, okay. Let me do this. So U sub level 4. Make the U sub, and you'll have leftover x terms. And in this case, you're going to have a u equals something of x, and you're simply going to solve for that x, right? So u might be like an mx plus b, right? Which means x is u minus b over m, right? Kind of thing, right? So you're just going to take your value of u and solve for x, and then substitute again, right? So here we go, example. The integral of x square roots of 1 minus x dx. Oops, dx. And these are the ones that I would say to you, I want a nice looking answer, okay? For most of these integrals so far, I've not had to manipulate, do any algebra at the end. These, if I ask you to do one, I will ask you to do some algebra to make it look nice, okay? And the nice is in quotes, right? So clearly an inside here, right? Do you agree? Right? I don't recognize it.
Yeah.
It's not a power rule. I don't see how I would do long division. I don't see a function in its derivative. Oh, I see an inside, right? That's my thought process is like that, right? So u is 1 minus x, and du is what?
-1.
-1 dx.
-1. Okay, yeah.
dx.
Yeah. So I can already see I need a negative, and I got to cancel it. And if I go make my u sub now, I have a negative of times the integral of a negative x square root of u du. Oops, sorry, this negative, right? This negative and this dx are du, right? So I made my u sub, but I have a leftover x.
Oh, can you go over it again, Professor?
Say it again?
Can you go over it again, please?
Well, is there a clear inside?
Yes.
Yes, so u is 1 minus x. No problem there, right?
No.
I took the derivative, I got negative dx. I multiplied by a negative on the inside, I multiplied on a negative on the outside to cancel them. But now, highlighted in green is du, right? Do you see it? Du is negative dx. So the negative and the dx, right? The negative and the dx became du, right? The inside became u, but I have a leftover x.
Okay.
Up soon?
We can't just take the x outside, unfortunately.
Why? You're right. Why?
Well, because it's
Because
on the outside.
inside
of the
it's a
integral.
slope. Outside it's the original function. Inside it's a slope. I can't get it outside of that integral without taking the antiderivative. Up soon. Question.
To like take the integral now, are we gonna like separate so that it's like the integral of the x times the integral of
No,
Yes.
that's a Calc 3 topic. So that would be if you're going into the engineering, you use multiple variables, x, y, z. Then it keeps adding. After we start talking about 3 space, which is the world we live in, we start talking about 4 space and 5 space and 6 space.
how I'll just wait.
Thank
See
you.
what we do.
Good. So I have to manipulate this to solve for x. So u equals 1 minus x tells me that x equals 1 minus u. So there's my last sub. So I get the opposite of the integral of 1 minus u square root of u du. So remember my method. I'm going to be left over I've got some leftover x terms. I gotta manipulate my u to get my x and sub back in, right? So this is this is power rule stuff here, right? I've got the opposite of the integral of 1 minus u times u to the 1/2 power du, and I'm going to distribute that u to the 1/2. So I've got u to the 1/2 minus u to the, don't tell me, 3/2 du. Right? Do we agree?
I think so.
Good.
It distributes in.
Yep, so I have power rules to do now. So I have u to the 1/2. I'm going to add 1 to the power and divide by the new power. I've got a negative u to the 3/2. I'm going to add 1 to the power, divide by the new power, and then add c. So
3/2 plus 2 or 3/2 plus 1?
3/2 plus 1, thank you. So that's a 5/2. So I have 2/5. I better not skip too many steps. You'll be mad at me. So I got the opposite of u to the 3/2 over 3/2. I'm sorry, forget the opposite. U to the 5/2 over 5/2, all plus c. Now I'm going to distribute and do my keep change flip. And I'm doing algebra here. I'm doing arithmetic. You don't have to copy me. Do it yourself. You know how to do this. You're in calculus. You're a top student. You don't have to copy me doing divide by a fraction. Do it yourself, right? Distribute a negative. You don't have to watch me do that. Just do it yourself. So in this particular case, I'm asking for a nice looking answer. So meaning when I say nice looking answer, I don't want fractions within fractions. I want it completely factored, right? So I'm going to factor out, I'm going to wait a minute. I think you might still be writing. So what do you see that I can factor out?
At least a 3/2 squared, I think.
Yes, I can factor out a u to the 3/2. I can factor out a 2, and I can factor out a 15. The 2 is obvious.
LCD of the
An
the
LCD,
two,
exactly. So I'm going to get 3 times u to the 2/2 minus 5 times 1. Yes. But I know what u is, so I could put that in. I have 2 times u. U is, I think, 1 minus x. Is that right?
Yeah, that's
Again, I'm not doing any calculus anymore, so clean it up.
Yeah, 3x minus, yeah.
There it is. And so why would I ask you to make this nice like this? Because when you're going to show me your check, you're going to use a product rule, right? When you show me your check on this one, you're going to use your product rule to show me that you got the antiderivative correct. Wow, intense lesson, huh? It's almost like we were on a camping trip. Intense.
We were intense.
Intense.
You summed up so little, like, this is thing, yeah. Before everything, please, I was just paying attention.
Say again, Markins.
Yeah, can you use about like so that I can see everything, please?
Oh yeah.
Thank you.
Almost. There it is. Make sure when you're doing problems that you every now and then do a derivative of your answer and get back to the original, right? Make sure you do that because I'm going to ask you to do that on the test. I'm going to say, show me your check, right? And if I don't say, show me your check, and you get it wrong, I'm going to write on the test, why didn't you check it, right? Why didn't you do the derivative? It's not difficult. We spent 5-6 weeks on derivatives. Well, we've got the most difficult problems coming up. I should be able to finish them all on Friday, which means we really will have 2 days of review on Monday and Wednesday, and then your Chapter 5 tests on Friday. The following week is 3 days of review. I most likely will only review Chapter 2, Chapter 3, Chapter 4. For the final exam, I am thinking...
Yes, sir. Can you do chapter 5 instead of like 2 or something?
Say again?
Oh, no, I was just thinking, when we review for the exam, I mean...
Yeah, but we'll just have done a 2 days of review for Chapter 5, so I don't think I'll need to review 5 again the very next week. But you know, you'll be in control. You'll tell me what you want me to do. If I don't do what you want me to do, you'll say, I'm having trouble on the complete the square integrals, right? Which is what we're doing Friday. But I'm thinking for the final exam, Chapter 2, Chapter 3, Chapter 4, Chapter 5, I've got 1 problem, 2 problems, 3 problems, 4 problems is what I'm planning. So for final exam, that's what I'm looking at.
How many corrections are going to be on the final exam?
So 10, right?
Okay, 10.
And you will have 2 hours to do it as opposed.
Mercifully, you brought it down to 10 from 12.
Yeah, it might still creep up to 12. But you all have to work on your speed a little bit. You can't get stuck on problems.
For sure.
You got to get things done. If you're stuck on something, you move on. If you made a mistake.
My thing is, I'll have a major error in the problem, and then I'll do those checks. Like I'll take, I'll be doing an antiderivative, and then I go back to a derivative. And I'm like, oh, yep, it's not going back. And then it's like, well.
But then you got to move on, because if you did something on like if you copied a problem over, I give you 1 point. Because you did something. If you leave it blank, it's 0 points. If it's completely like you're making things up, probably 0 points. If you make a real effort, I'm going to give you a couple of points, and that's better than getting a 0 on another problem because you never got to it. And I personally believe in, if you let things go and move on to another problem, it might unlock something, and you go, oh, I remember, I know what to do, and you go back to the problem, right?
Yeah, 100%. I have big issues with getting locked down on perfectionism.